Well, welcome, folks. This is Mr. Bergmann, and we are starting a new unit, a new section, really, in our quest. We're going to be starting a discussion of geology. Mainly, it's just a study of the Earth and Earth science and lots of things. And our first unit, we have Unit 1, and this is going to be Chapter 1, which happens to be on volcanoes, and then Section 1. We're going to be dealing with the question is, where are the volcanoes? Plus, we're going to learn about something called map projection. So that's our main goals for here. We have a volcanic eruption here. This is from your textbook, so we'll see how this goes. Now, I want to also talk about something in your book. In your book, in each section, there are what they call GeoWords, geologic words. The word geo means earth. And so these are the words that you need to have definitions of. And I need you also to not only have a definition, and I'll go over those in the podcast, but you also need to have a picture. So I need a picture of each that illustrates each of the GeoWords. And I'll go through these in the podcast, but in your notes, you need to have a picture. You could either do that beforehand or after the fact. I don't care. So the first thing I want to talk about is something called a mid-ocean ridge. Now, a mid-ocean ridge is easy to understand. It is a ridge in the middle of the ocean. Think of it. All right, the mid-ocean ridge is a nearly continuous mountain range in the ocean. Each ocean basin has its own ridge, most of which are near the middle of the basin. Most of the volcanoes on the Earth are found along mid-ocean ridges, and this is where magma is rising to the surface. So let's kind of go back to my map here. So if you look at the map here, we can see, basically drain the water out of the ocean, so to speak, and you can see a ridge here along the Atlantic Ocean. That is a mid-ocean ridge. You can see one extending from California down through near South America, and then etc. You can see these ridges. I probably should change the color here. You can see the mid-ocean ridges throughout the bottom of the ocean. And this is what's happening at the mid-ocean ridges. Magma is rising to the surface, which is hot molten lava as it rises to the surface, and this is what it looks like deep underwater. So that's a mid-ocean ridge, and here's our definition we've talked about. The second thing I want to talk about is something called a rift valley. Now, in a rift valley, something called plates are separating. Now, we're going to learn, our chapter 2 is on plate tectonics, and so we'll talk about plates later, but the plates are separating and it causes a gap, and so you can see the kind of how this works. You can see how the hot liquid rock, which is called magma, rises. It eventually splits things apart. It can eventually lead to oceans as well, which we'll learn about later. So here's the official definitions. There are two different types actually of rift valleys, those that occur at the top of mid-ocean ridges and those that occur on land. So there's land ones and water ones, right? Both of them are the result of two plates on the Earth's surface spreading apart from each other. It's a valley, which is a rift. Now, to think about the word rift, all right, if you have a rift between two friends, you don't necessarily copy this down, this would be a split or a break. So, like if you're going out with somebody and you have a rift, you probably are going to break up, right? Okay, I get it, all right. Now, let's talk about magma and lava. Cool picture here. This would be a good one to illustrate. Lava is essentially molten rock on the surface, and magma is molten. Molten, by the way, means liquid. Liquid rock underground. So once the magma reaches the surface, it's called lava. So simply put, magma is the molten rock found underground. Lava is molten rock found on the surface. So that's pretty simple, isn't it? Okay, now map projections. Let's talk about map projections. The problem that we have with map projections is that the world is a sphere. And how do you take a spherical object and make it flat on a piece of paper, so to speak? How in the world do you do that? So you have a problem, is how do I make this in a flat piece of paper? Well, the answer lies in how we do maps. You see, the problem is that, as you can see, if I take a piece of paper and make a grid on, say, right here, we can make a cylindrical projection, but the problem is that it's you've got more space. So what really happens when you do this is actually what we call a Mercator projection, is you distort the northern portion, okay, and the southern portion, and then you see each of these lines right here. These lines have the same distance as this line, but on the piece of paper they look to be different in size, but on the map or on the globe itself they aren't. And so they've got different kinds of projections: conic, cylindrical, etc., etc. Okay? So a map projection is a two-dimensional representation of the Earth's surface that maintains the scale and spatial relationships. Let's take a couple of looks at these. There are many types of map projections, each useful for its own applications. We're going to talk about Mercator projections. It's a cylindrical map projection. The further north you go, the more distorted it becomes. The further south you get, the more distorted you get. So extreme south and extreme north gets very distorted. It is most accurate near the poles in terms of the correct sort of size of a island or something to that effect. Here is the Mercator projection. So if you look carefully again at the lines, this line right here, all right, this distance between this line and this line is the same as the distance between these two. Well, of course, those look very different. But the net effect is that Greenland, at least in this example, looks much larger than it is. But if you look at it, let's zoom in on the globe. If you look at it here on the globe, Greenland is not near as big as you would think it would be. And often it also makes Alaska looks huge. Alaska, I mean, if you were to take Alaska right here, right, as it's on the map and drew it in the United States, I mean, it would take up almost all of the United States. And though it is our largest state, it is not nearly as big. It's probably only as big as this right here, something like that. And that's because of the nature of the map. That's called a Mercator projection. How they actually build a Mercator projection, you can kind of see on the picture right here. They take a cylinder and they put it around a globe, and then they kind of wrap it around, and that's how they do that. Okay. All right. There's another one that's interesting called a Mollweide projection. It's a pseudo-cylindrical map projection generally used for global maps of the world. And notice, of course, how we get the curve. And then now Greenland looks not quite as big as it really is. Okay. And here is it zoomed in. It's pretty cool. All right. Let's talk some more stuff. Let's talk about some volcanoes in the ocean. So there's volcanoes in the ocean.